We've got a lot of words in this problem, but the long and the short of this entire paragraph up here is basically describing this picture. That's it. So I'm not going to dwell on that stuff. I'm just going to point out that the reason this is a difficult problem is because this is not a right triangle. If you look at the angles here, right, that's 70 degrees, not 90. And these ones over here, those are pretty obviously not 90 degrees either, these things. So we need to have a way of solving for missing sides, like this one, without using SOHCAHTOA or the Pythagorean theorem or whatever. Now, the method you're going to use, you may not have seen yet. It's called the law of sines or the law of cosines. You have to decide which of these laws is appropriate. And the way you do that is by recognizing what the law of sines needs. This law requires something called a matching pair. Okay, in other words, if you have a matching pair of angles and sides, you can use the law of sines. We don't in this problem. Take a look. I know this side right here, but I don't know this angle. And I know this side over here, but I don't know this angle. And I do know this angle, that's nice, but I don't know that side. So I don't have a pair of an angle and the opposite side that I can use. That means we are not using the law of sines. Okay, I'm not going to describe how we would use the law of sines because this is not a law of sines problem. There will be other examples where you have to work through something like that. The law of cosines is a different law. This is what you use when law of sines doesn't work. And there's a formula. It's kind of a big one. It would be good if you memorized this, but oftentimes it's either given to you or some of the answers are given to you so that you can kind of remember what the law of cosines should look like. But what it looks like is basically starting off like something about Pythagorean theorem, right? That kind of seems like a Pythagorean theorem thing. And then there's this adjustment over here. And the adjustment is 2 times b times c times cosine of a. That's this part right here is to adjust for the fact that we're not actually dealing with a right triangle. We need to modify the formula somehow because it's no longer Pythagorean. So what I'm going to do now is apply this formula to this triangle in here. And you see this little side right here? That's what I want. That's going to be side A, making this angle up here angle A. And the other sides, doesn't matter how you label them. I'm just going to label B and C. As long as you're consistent and you recognize that angle B is across from side B and angle C is across from side C. Okay, so now let's plug in the numbers from the picture and see what we get. A squared, I still don't know what that is, equals, let's see, B squared, that's going to be 5 squared, plus little c squared, that's 4 squared, minus 2 times b times c times the cosine of, need a little bit more room here, times the cosine of the angle A. And angle A is that 70 degrees. Okay, so that's a squared. And obviously, if you want A, you're going to square root that whole thing. So if you understand the basic framework of the law of cosines, you can rule out a couple of these, the ones without square roots. And then it's just a matter of remembering which angles are important, right? 51 degrees, that's not important because it's outside the triangle. I need an angle inside the triangle, so we can rule that one out. And now it's a guess between these two. Do you remember the basic formula? Was it a 2bc cosine A in the positive or a negative? What was the adjustment there? Well, it's a negative. You got to remember that one. And that leads us to our final answer right here. Wrong. Right here, the one with the minus sign.